how we get the graph of the logarithmic function. The logarithmic function is the inverse of the exponential function. So the part that's circled by the ellipsis is the graph of the logarithmic function. And the reason why I chose this picture is the inverse function, the graph of the inverse function is a reflection of the original graph on the y equals to x line. It's like you put like y equals to x, you draw that line, and then you use it as a mirror. And then when you reflect it, that's going to be the graph of your inverse function, because you are switching the y and the x. So it works exactly like a reflection on that. But that's not really important here. It's just like a cool thing to notice. So what happens is the domain of the logarithmic function has to be positive numbers only. And while the exponential function goes through the point 0, 1, the logarithmic function will go through the point 1, 0. Like everything is inverted, right? And then the next slide, I have objective 2, which is, okay, how do I convert one from the other? Given log of 2, log base 2 of 64 equals to 6 exponential form, and then 3 to the power 5 equals to 243. How do I write that in log form, right? So I need a whiteboard again, please. So I just want to review a little bit the concept of inverse function. Remember when we had like f of x equals to 2x, say, then the inverse function of f, we write it like this in math. We put a -1 on top of f. That's the notation we use. The inverse function of f is dividing by 2, right? If you just think of it in terms of inverting what you just did, this is why I kept it simple. So it's like I'm doubling it. So the inverse of doubling it is halving, right? Just like if f of x equals to adding 3, then the inverse of that operation would be subtracting 3, right? This is just a like simpler way for us to understand what does the inverse mean. The inverse means what function you apply to the result to get back your original input. So if when we say that the log function, the logarithmic function is the inverse of the exponential function, it means that a log of x gives me back x. And because the exponential function, the result of the exponential function is never negative, log cannot have negative numbers as its input. So the domain of the log function is always numbers greater than 0. Okay, but then for the exercise, what we need to know is this. So it's like we have, we say log 2 of 64 equals to 6. What we mean is the same as 2 to the power of 6 equals 64. This is what the question is asking you to do. The log of something in a certain power means, what should I raise this to the power of to get my 64? And the result is 6. If you raise 2 to the 6, you get 64. This is all it means. It looks complicated, but it's actually not that bad. Yeah. And then here, 3 to the, conversely, if I have 3 to the power of 5 equals 243, how would I write this as a log? I'll say log of 243 in base 3 is equal to 5. Like the two sides are the same. It's just like two different ways of saying the same thing. Like this basically says like, what should I raise 3 to the power to get 243? And the answer is 5. What should I raise 2 to the power of to get 64? And the answer is 6.
That's not as hard as I thought it was going to be. So that's a relief.
And then usually when the base is not clear, because the base here matters, right? When people don't write anything, it's usually for mathematician means that you are using base E. that number between 2 and 3 that I said before.
Mm.
Non-math people think it's 10, like when they don't. So you really need to be careful. They need to say, yeah, like when they're too lazy to write the little number, they need to tell you like, what is it? Which base are you working on? Because the base matters. Yeah. I think that's it.